In this video, I will be solving electrical network using superposition theorem. So superposition theorem, what it states, if it is in a linear network containing more than one independent sources, then the resultant current in any branch is the algebraic sum of the currents that would be produced by each independent sources acting alone. So if it is a voltage source, then you have to replace it with a short circuit, and if it is a current source, you have to replace it with a open circuit when you are removing that particular source from the network. So this is the problem I am going to solve. So here in this network, you can see that there are two sources, 4 volt and 6 volt given, and the question is find the value of current flowing through 8 ohm resistor. So according to the superposition theorem, what we do is we'll be considering only one source at a time. Suppose we are considering 4 volt, then we will be removing the 6 volt from the circuit by replacing it with its internal resistance, or if it is not there, then it is by a short circuit. Okay, then you will be finding the current through this 8 ohm. Then what we do in the second step, we will consider the 6 volt and remove this 4 volt from the circuit by replacing it with the short circuit and find the current through 8 ohm. So the final current through this 8 ohm will be the algebraic sum of the current found by using this 4 volt separately and 6 volt separately. Okay, this is how the superposition theorem we have to apply in this network. Okay, so first one, we will, as a first step, we will just consider 4 volt acting alone. That means we are removing the 6 volt source. Okay, so I'll just redraw the diagram here, because 4 volt means we have to consider only one, and the 6 volt we are replacing it with a short circuit, and we are drawing the diagram here. This one is 4 volt, this is 5 ohm, this is 10 ohm, and this is 12 ohm, and this one is 15 ohm, here it is 8 ohm. Okay, so this is the network. Now what we do is we'll be finding the current through this 8 ohm. So for finding the current through 8 ohm, we have to simplify this network. Okay, what I'll do is, here if you observe this network, you can see this 12 ohm and 8 ohm are in parallel. Okay, this 12 ohm is in parallel with 8 ohm. So we can just redraw the diagram, and the equivalent circuit we can make it. So here it is 15. So 12 and 8 in parallel means 12 into 8 upon 12 plus 8 will be the equivalent resistance of 12 and 8 in parallel. So I'll be getting it as 4.8 ohm, and here this one is 10, this one is 15 ohm, and this one is 5 ohm, and here it is 4 volt. So let us take this current. Okay, I'll be just assuming the current through this one as I1. Okay, and this be the total current I, so that you can easily identify. So we want to find the current through this 8 ohm. Okay, so I'll just make here as I dash, let it be. Okay, the first one here, this is I, this is I1. Okay, now how will you find this? Now again you can see this 10 and 4.8 ohm are in parallel, so we can again simplify this network. So here we have 10 ohm in parallel with 4.8 ohm. So we can redraw the diagram with the equivalent resistance. Okay, so here this one is 15 ohm, and that parallel combination, this 10 and 14 is in series. Okay, 10 and 4.8 ohm is in series, sorry, it is not in parallel, just 10 and 14. So you'll be getting 10 plus 4.8, so 14 point, 10 and 4.8 ohm are in series. So this one is 5 ohm, this is 4 volt, and here I have taken the current through this one as I1. Okay, this branch. Okay, and this one. Okay, fine. Now we know this 15 and 14.8 are in parallel. Okay, so we can again redraw, that is 15 ohm is in parallel with 14.8 ohm. We'll be redrawing the diagram again, so it is, we'll be getting it as 7.45 ohms. Okay, so the current is here, the current is, okay, this current is I, okay, this is I, fine, 7.45, and this one voltage is 4 volt. So what is the total current? You can find this total current I is nothing but, it is now, this one is 5 ohm, so this is in 5 ohm and 7.45 are in series, so I is nothing but 4 divided by 5 plus 7.45, so we'll be getting the answer as 0.32 amperes. Okay, got the answer. Now just observe this diagram, this one. You can see that the current I1 in the circuit, see, we can apply voltage divider rule here. Okay, this one, the second diagram, this diagram I am talking about. So you can find this I1 is nothing but, it is, you can use the current divider rule, that is the total current into resistance of other branch divided by the total resistance. Okay, so current division by current division rule, I can find the value of I1. So I1 is nothing but, its total current is 0.32, we already found here, 0.32 into this diagram. So see, the resistance of other branch, we want to find I1. I1 is the current which is flowing through this series network, 10 ohm and 4.8. okay, so the resistance in other branch is 15 ohm, so it is 15 divided by 15 plus the total resistance, that is opposite branch divided by total resistance. So 15 divided by 10 plus 4.8 plus 15, so it is 14.8. okay, so we'll be getting the answer as 0.16 amperes. So what is this 0.16 amperes? It is the current through this branch, 10 ohm. Okay, so that one we got it as 0.16 amperes. Now you can again find by current division rule, we can find what is the value of I dash. I dash is equal to, that is, see here, now we got the value for I1. Now just check this diagram. This diagram. Now the total current reaching at this junction is I1. It is getting divided into I dash, right? And the current is flowing through 12 ohm. But we are interested in finding the current through 8 ohm resistor only. So that is I dash given here. This one is I dash. Okay. So now we will be finding that current I dash by current division rule. I dash is equal to, the total current is 0.16, that into, just see this I dash here, what is the total current into, that is 0.16 ampere is coming here, that into resistance of other branch. What is the resistance of other branch? It is 8 ohm and 12 ohm are connected in parallel, so the resistance of other branch is 12 ohm divided by total resistance, that is 12 plus 8. So we'll be getting, it is 12 divided by 12 plus 8. So the answer is 0.096 amperes, and the current direction is downwards because you have assumed it as in this direction, down, and you got a positive answer, means the assumed direction is correct. Now the second step is when 6 volt source is acting alone. That means we have removed this one, 6 volt sources acting alone, means in this original diagram we are removing this 4 volt source. Okay, so that 4 volt source we will be replacing it with a short circuit. So I'll be redrawing the diagram. So this 4 volt I am keeping it here as a short circuit, then 6 volt is here, 6 volt, then we have 5 ohm here, and we have 10 ohm, we have 12 ohm, and then here we have 8 ohm. So this is the current through 8 ohm we are supposed to find, right? So 15 ohm here. Okay, now we'll just here in this diagram we can see that this 5 and 15 ohm are in parallel, 5 parallel 15 ohm. So we can just simplify the diagram and redraw it. When 15 and 5 equivalent is, parallel equivalent is 3.75, so that we will do here. This one is 12. I'm just redrawing the diagram. Here just see 6 volt here battery, and this one is 3.75 ohm, that is nothing but the equivalent of 5 and 15 ohm in parallel. Now this 10 ohm is here, then this is 12 ohm, and this is our 8 ohm. Okay, now we can just mark the currents there. Now the 6 volt is batteries here, so the total current is coming like this. Now let me put the current through 8 ohm as I double dash. Okay, now we can find this one. You know, this 3.75 and this 10 ohm are in series, so I can redraw the diagram. So it becomes, this one is 12 and this is 6. Okay, this is 6 volt, and here I have 8 ohm. Okay, and this is 12 ohm, and this one is 10 plus 3.75, that is 13.75 ohms. Okay, here, and now the current through this 8 ohm, I have marked it as I double dash. Now how will you find this one? We know this 8 and 13.75. You can see that this 8 is in parallel with 13.75 ohms. Okay, so you can just take the equivalent of that one, 13.75 in parallel with 8, and I can redraw the diagram here. So the equivalent resistance is 5.06. Then I have this 12 ohm. This is just to find the total current. I'm just simplifying the network to find the total current. You can just see. Now here, this one is our total current I. Here it is I. Okay, so how will you find this current I? I is nothing but the total voltage divided by the total resistance, that is 5.06 plus 12. So that you will be getting it as 0.35 amperes. Okay, so the total current you got now. So now you can apply the current division. Now we have this total current. See this diagram. We have the total current I. We are supposed to find I double dash. Okay, so that is the current through 8 ohm. So by current division rule, we will be getting I double dash. This is I double dash is equal to, that is the total current into the resistance of other branch. What is the resistance of other branch? It is 13.75 divided by the total resistance, that is 13.75 plus 8. So that you will be getting it as 0.22 amperes. Since you are getting a positive current, the assumed direction is correct. So we have assumed the current to be flowing 8 ohm in downward direction. Okay, so that is because direction is very important while applying the superposition theorem, because you have to take the sum or the difference depending upon the current direction for getting the final current which is passing through the 8 ohm resistor. So now the third step is by superposition theorem, total current I is equal to I dash plus I double dash. Let me put it as 8 ohm. Okay, so it is, this one is, we already got the values, that is 0.096 plus this one is 0.22. See, 0.096 we got when we considered 4 volt source, and 0.22 when we considered 6 volt source. So this, when you take the sum, that will be the current which is flowing through 8 ohm resistor, and this is how we will be applying the superposition theorem. So 0.316 ampere is the value of current which is flowing through 8 ohm resistor, and you got it is in the downward direction. Okay, I will solve one more problem. Okay, let me take one more problem. Find V1 using superposition theorem. Okay, so we are going to find the voltage for a particular network. So this network is given, it is 5 ohm is there, then here we have a 2 ampere current source, then this one, here we have a resistor connected, here again you have a resistor connected, then it is a 100 volt battery again here. Okay, now this one is the resistor. Okay, now 80 volt, this one is 100 volt, this is 2 amperes, this is 5 ohm, This one is 25
Showing pictures that
ohm.
match.
This one is again 25 ohm. Then here it is 30. Okay, so voltage V1 is given, so this is plus, this is given in the question V1. Okay, so V1 we can see it is the voltage across this 25 ohm resistor. Okay, now what is the step? First step, you can see that there are three sources, so we have to find three currents considering each source separately. So first let us consider 80 ohm is acting alone. So when 80 volt is acting alone, means we have to remove the 2 ampere and this 100 volt. So 2 ampere we will be removing by open circuit, and 100 volt we can remove by short circuit. So this one will be getting this 100, we are just removing that. Okay, so this is the diagram. We'll be getting, this is 80 volt, this is 5 ohm, here this is 25, here it is 30, this one is 25 ohm. Again, these are all in ohms. Okay, and this one is plus minus, V1 is given. Okay, this is the diagram after removing the sources. Now we can find, let us now just see this 30 and this 25, we can see it is in parallel, right? So I can just redraw the diagram. I'll be redrawing it, this 5 ohm, this 25, then that 30 and 25 in parallel. I'll be getting the equivalent as 13.64 ohm. This is 25 ohm, and across it we have V1, that is we are supposed to find it. This is 5 ohm and this is 80 volt battery. Now, and let us take this current as I. So what is the current I? I is nothing but the voltage divided by the resistance, that is we already know, 5 plus 25 plus 13.64, that is equal to 1.833 amperes. Okay, that we got. Now V1 dash we are finding. So what is V1 dash? It is, we can apply Ohm's law here. We know the resistance, we know the current through that resistance, so we can apply it as 25 into I. So I, we got it 1.833, so it is equal to 45.83 volt. Okay, so this is the first value of voltage. Now second is when 2 ampere is acting alone. So what we are doing here, just see, now we are considering from the original diagram, we are removing this 80 volt and 100 volt. So this 80 volt will be replacing with a short circuit, and 100 volt also will be replacing with a short circuit. So we can redraw the diagram like this. The 2 ampere source is there. Now we have this 2 resistors. Okay, here this we have kept a short circuit, here also we made a short circuit. This resistance is present, this is 25, this is 25, and this is 30, and this is 2 ampere, and this one is 5 ohm. So all the resistance are in ohms. Here plus minus we have the voltage V1. Okay, let me put it as V1 double dash there, because we are considering see this one I just made it V dash. Okay, sorry, this, the first one I made it V dash, second one I'm just making it as V double dash. Okay, V1 double dash. Now the current through this 25 ohms we can find it, right? So by current division rule, current through this 25 is this 25, I 25 ohm is equal to the total current is what? This 2 ampere. This diagram, this 2 ampere is coming here. You can see it is going in this branch 30 ohm and then 25 ohm. So the current through this one, we can just see Okay, what I'll do is to make you understand, I'll just redraw this diagram, okay, because otherwise you won't understand, because one parallel combination is there here, okay. So this is that 25 ohm, so we can see this 30 and 25 are in parallel, okay. So I'll just do the parallel combination. This is 13.64 and this one is our 25. This is 25 and this is plus minus, this is V1 double dash, okay, and this is 5 ohm. Now this is 2 ampere. Now we are going to find the current through this 25 ohm. So what is that? This total current, okay, that 25 is nothing but it is by current division rule, total current into the resistance of other branch, means this branch, since it is both are connected in series, so the same current will be flowing through this one. So the resistance of other branch is 5, that divided by the total resistance, that is 5 plus 25 plus 13.64. so we'll be getting the answer as 0.23 amperes. We know this, just see this diagram, the current is like, okay, I'll just show this one so you will understand. See, the current is flowing like this, right? Okay, so it is going 0.3 ampere is going upward direction. So here we will be writing in upward direction because this direction is very important. And okay, now by current division, so V1 double dash is equal to 25 into the current through that resistance. So the current is 0.23, so 25 into, so this one I can write it as minus 0.23 amperes in downward direction, because the previous current you just see we have taken, okay, that is fine. Now here 25 into, because we want it in the same direction, so I'm just taking this direction, 25 into 0.23 amperes, that is minus 5.75 volt. You got it, okay. Now what about this third step? We have already see 80 volt, 2 ampere and 100 volt. With that we found the voltage across this 25 ohm V1 dash when 80 volt was acting along. Then we found V1 dash when that 100 volt was acting, right? Okay. Sorry, this not 100 volt, 2 ampere was acting. Now the third one is when 100 volt source is acting along. So we will be redrawing the diagram. We'll be getting the diagram like this, 25 volt, then we have this 100 volt. So that current source we are replacing with an open circuit, and the 80 volt we are replacing with a short circuit. So here we will be getting 25 ohm, here it is 25 ohm, this is 30 ohm, this is 100 volt, and this one is 5 ohm, okay. So now I'll this one 25 ohm here plus minus, it is, let me take it as V1 triple dash, okay. This is the third source. Now I'm just assuming the current because it is like a mesh, we can see, so we can find the mesh currents. It will be easy if you use mesh analysis, okay. So depending upon the circuit you can use mesh analysis, but be careful when you are doing this superposition theorem, don't do source conversion, okay. So now we'll be doing KVL to mesh 1. Will be when you are applying KVL to mesh 1, this is plus, this is minus, so minus 5I1 minus 25I1, then we'll be again getting minus 25 into the current through this 25 ohm is, it is common between two mesh, so it is I1 minus I2, I1 minus I2, that is equal to 0. So simplifying this, you will be getting 55I1 minus 25I2 is equal to 0, that is equation 1. then KVL to mesh 2. KVL to mesh 2. This is the mesh 2. So when you apply here, you can see this is plus, this one is plus, this is minus. Okay. So minus 30 I2. This voltage, so it is from plus to minus, so we'll be giving minus 100. Then minus 25 into I2 minus I1 is equal to 0. So when you simplify this one, we'll be getting minus 25 I1 plus 55 I2 is equal to minus 100. This is our equation number 2. Okay, so we are going to solve this two equations. We have two unknowns and two equations. So solving, we'll be getting I1 is equal to minus 1.042 amperes and I2 is equal to minus 2.292 amperes. Now what is this? V1 3 dash is equal to 25 I1. So 25 into I1 we already got, it is minus 1.042. So this is minus 26.05 volt. So we got all the values of the voltage across the 25 ohm by considering the sources separately. Now what is the total? So by superposition theorem, so you have to take the sum of all those voltages which we found individually. Okay, so V1 is nothing but V1 dash plus V1 double dash plus V1 triple dash. Okay, so V1 we got it as 41.83 and V1 double dash we got it as 5.75 and this one as 26.05. Okay, so you got the answer as 0.03 volt. Okay, so this is the answer for this voltage across this 25 ohm. Okay, I'll just show the diagram. This one, this question. Okay, so we were supposed to find the voltage across this V1. So what we have done is we were having three sources, so we considered each source separately and found the voltage across 25 ohm independently. Okay, then the total voltage across this 25 ohm is nothing but it is the sum of all the voltages found independently. Okay, and by applying, that is a superposition theorem. Okay, I hope you understood. Thanks for watching. Thank you.